Thank you. Good morning, class. We are in mathematics class, and today we are handling linear programming in mathematics, and specifically focusing on graphing of linear inequalities. Linear programming is a concept that is in Form 4, and there are various aspects or components of linear programming that a student must be able to understand before drawing the linear programming inequalities. 1, identifying the number of unknowns in the expression. 2, obtaining the coordinates of the line. 3, drawing the Cartesian plane followed by an inequality line. Then 4, shading the unwanted region. Those are basics within linear programming when a student is to optimize. But in this lesson, we are going to focus on how a student can draw those given lines on a Cartesian plane. And therefore, the main objective here is to represent lines using a digital tool called Geogebra that we'll be using in this lesson. In Geogebra, it is a class of geometrical algebra. A digital tool called Geogebra can be applied to easily expound on the drawing of the lines instead of using geometrical sets. And if you look at our first slide here, we have got the initial or the original tools that were used to draw the lines. We have the geometrical set equipments that are applied. But in this concept, we will be using the digital tool called Geogebra to draw the lines, even before they shade the unwanted region. And so the focus will be that. And to work with few examples that we may use to conceptualize the concept. The first example will be the equation of the line given. And remember, our focus is the line itself, not really the linear inequality by shading the unwanted region. And so in the first equation, we have 2y plus 3x is equals to 6. The second equation is y plus 5x is equals to 8. And lastly, we have 4y plus x is equals to negative 7. The interest of linear programming is to come up with what we call the wanted region. The wanted region that a student can use in optimizing. And therefore, in this lesson, we will be drawing the lines to identify the wanted region without drawing. And therefore, let's get to the Geogebra, this digital tool, and then we see how to draw the lines. Now, on the board is our Geogebra. And up here, we have the commands in Geogebra that you can use in drawing the lines. To the far left, we have the input section where you can easily input the equation that you desire to draw. Then afterwards, it will appear on the line, on the Cartesian plane, rather. And therefore, let's use the first equation that was given. The first equation is 2y plus 3x is equals to 6. I will come to the input section of the Geogebra here. Then I write 2y plus 3x. 2y plus 3x is equals to 6. And you can see the line appears. This is the work of Geogebra. It is a digital tool. You easily come up with the line. And because in linear programming, we have more than 3 lines intersecting to give the wanted region, I will bring in the next line, equation of the line. And the next equation was given as follows. Y plus 5x is equals to 8. I input it here. Plus 5x is equals to 8. And you can see the line comes there. We have y plus 5x is equals to 8. And our concern is to get the wanted region, the region that will be satisfying the points that are meeting or the equations that are meeting. Then I have the third one here. The third equation is given by 4y plus x is equals to negative 7. I input it here, 4y plus x is equals to negative 7. I have the line drawn. So all the 3 lines, and Geogebra will automatically give them like number them. We have equation 1, equation 2, and equation 3. And so you can see my first equation is here, equation 1, equation 2, equation 3. All the 3 lines are intersecting at a point. And the point of intersection, I can mark it. I can also use GeoGebra here to mark a point. I go to that point, then I want to mark a point within the wanted region. Then I come within the wanted region, I will mark a point. It's marked A. And so it appears here. The whole of this region, the point of intersection of the 3 lines, that is the wanted region that I can use to optimize, my linear programming concept here. And therefore, this is the best digital tool a student can use in coming up with the wanted region of given linear inequalities in linear programming concepts. Thank you.